Today I will be talking about electrical transmission from a neuron to a synapse and its route along the axon chain and how all of that happens. I'll be using this orange slice as an example of a neuron. We're going to follow this rainbow road down. This rainbow road is actually going to be our axon chain, which leads us to our synapse, which is represented by this dragon fruit because all the seeds remind me of that cool little spark that happens in the synapse. So everything above it is everything inside of the axon membrane. Everything below it is everything outside of the axon membrane. So as you can see inside, we do have quite a few different types of ions. And as you can see, the ions are either positive or negatively charged. So chlorine and our organic ion here, which will be represented by a big protein, are negatively charged, while our sodium ion and our potassium ion are positively charged. And the charge is due to the ions on both inside and outside of the membrane. So even though they are both positive and negative, which would cancel each other out, positive and negative, which would cancel each other out, we actually remain at a negative 70 millivolt. So it is not like a zero cancels each other completely out. We remained actually more negatively charged inside of this axon chain than what you would think. So say we are resting right now, right? There's nothing going on, no information needs to get from here to there. But say there is a distraction, something that happens, and now a stimulus has occurred. And because of that stimulus, so that stimulation will now cause movements of the particles on the axon chain. So they would cause them going from inside and out. For this example, we'll be using the potassium and sodium as the ones going in and out. So we're going to put this one out, and we're going to put this one out. So this stimulus caused the potassium and sodium ions to go ahead and move outside and inside of the membrane. They go in and out because now there was something that stimulated us. So from the neuron, we have to send over a message. So because of that, there's a lot of movement. It's actually kind of like a little wavy movement, and that allows for these ions to move in and out a little bit more freely. But that also means that the charge has now changed. So now, during action potential, we're actually looking at so now we went from negative 70 millivolts to a positive 40 millivolts because of all that movement as well. The movement is what carries out that message all the way across down to the synapse. So say we got startled over here, all that movement would let us know, hey, something startled us, there's a distraction here. Okay, and just recapping, we were able to demonstrate resting potential and action potential in a neuron and through the axon chain. So again, when there is no stimulus, it is at resting at a negative 70 millivolt. And when there is stimulus or like a message needs to go from a neuron to the synapse, it is now a positive charge of 40 millivolt. And it also allows certain ions to go in and out of the membrane. A little bit more easy.